All right, here is our introduction to probability. So we begin with the question, if you flip a coin 4 times, list all the possible outcomes. So it could be like the first time you flip the coin, it's tails up, and then it's tails up, and then it's heads up, and then it's tails up. So we say that this is one specific outcome of this experiment that we're performing. So off to the right, you have a space for listing all the different possible outcomes. And so to make it more intelligible, I just wrote in the heads and everything else would be tails. So you see how I started with tails, 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 tails. So you should fill these in with T's. And then I started with, all right, so there's 4 tails, 0 heads. And then the next 4 different outcomes would be 1 heads up. And so we could have one here, 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 here. I'm being nice and systematic. And the next situation we'd have 2 heads up, and so we'd have these, and these. And the next 4 situations or outcomes, we would have 3 heads up. So notice tails, 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 nice and systematic. And then in the last outcome, we would have 4 heads up. So get that or figure it out on your own and write in the tails as well. Notice how there are 2 when you're flipping a coin, all right? There's 2 possible outcomes. One is heads up, one is tails up. And so there's 2 possible outcomes, and we're flipping the coin 4 times. And that is 16. And notice how there are 16 possible outcomes here. Okay, so when we talk about this vocabulary, let's do the probability question soon. But when we talk about what is the experiment, well, that's the entire process. So in this situation, flipping a coin a bunch of times and looking at the probability, that's what we would talk about as the experiment. Outcome is one result from the experiment. So this right here would be an example of an outcome. Heads up, heads up, heads up, heads up. The sample space is all possible outcomes. So that entire chart is the sample space. And let's do this so that we have this. That's a space, not a spay. Space in our notes. So sample space is all of that. Okay, each of those 16 different outcomes. And then lastly, event, one specific thing that happens. So in this example, it would just be flipping a coin. All right, so one specific thing that happens. Given this, let's take a look at some probability questions. So I think that intuitively you understand this, and you may have seen this in math class. But our first thing says, how many of these outcomes have 2 heads up? So we'd be looking at these here, all right, 2 heads up, and there's 6 of them. So if we said, what's the probability of 2 heads up? It'd be 6 out of 16. Number 2 says, what is the probability of flipping tails 4 times in a row? So there's only one of those, and that's this. So there's one outcome that yields that result. And so 1 out of 16 would be the probability or likelihood of that happening. What is the most likely outcome? So this question's a little vague. All right, what's the most likely outcome? Because this outcome is just as unlikely as this outcome, is just as unlikely as this outcome, is just as unlikely as this outcome. So when we're talking about 4 specific things happening in a row, the probability of each of those is 1 out of 16. So we could say, oh, they're all the same. And the probability of each of these specific outcomes happening is 1 out of 16. But if it were more general and saying, well, what's the probability, which of the situations is most likely? So 2 heads up or 3 heads up or 1 heads up or no heads up or 4 heads up, well then 2 heads and 2 tails, because that is this situation, this is most likely. And let me use some color here to break these down. So that's one possibility. Here's another possibility. Here's another possibility. Here's another possibility. And here's another possibility. So we could say that this is 4 tails, 0 heads. This is 3 tails, 1 heads. This is 2 tails, 2 heads. And this is 1 tail, 3 heads. And this is 0 tails and 4 heads. Okay. 1, 4, 6, 4, 1. Do those numbers look familiar? Yeah, look at that connection. Pascal's triangle. Cool. Okay. What is the least likely outcome? Well, if we're talking about a specific situation, having all heads up or all tails up is the least likely of the situations. Number 5, what is the probability of flipping at least 2 tails? So that means we could have at least 2. So we could have 2 tails up, we could have 3 tails up, or we could have 4 tails up. So 2 or 3 or 4 tails up. So not these, but here. So we have 6 plus 4 plus 1. Who did this? Torville? So that would be, yeah, I'm guilty. 11 out of 16 would be our probability of at least 2 tails up. And so that excludes 1 tail up and no tails up. So we take 5 out of the 16, giving us 11 out of 16. All right, a little bit about probability. So let's talk about cards. I know. So our definition of probability, to keep it simple, is it's just the number of specific outcomes that yield that result over the total possible outcomes, or sample space. All right. For example, in flipping a coin, we have 2 possible outcomes. So our sample space would be heads up or tails up. We're just flipping one coin. And the probability of tails up, there's 1 specific outcome out of 2 possible outcomes, 1 over 2. And so you've heard that as 50-50, or 1/2, or 50%. Let's talk about cards, and we will do a little, I don't know, play poker or something in class. But for those of you unfamiliar with a deck of cards, there's 4 different suits, okay? So they have these little pictures on them. There's 52 cards total in a deck, and out of each of the suits, there's an ace, which is kind of really good, like a 13 or 14, or, well, I'm not the best card player. Or sometimes ace counts as 1, and then there's all the numbers, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the jack, queen, and king are what are called face cards. All right, so a little bit about cards, because we will be using that situation to calculate probabilities. So, example, 5-card poker hand is drawn from a standard 52-card deck. So you're sitting at the table, and they, the dealer, hopefully they're not cheating, and they pass you 5 cards. And the order of these 5 cards doesn't matter, right? If you have a 2, 3, 4, 5, 6, that's the same thing as having a 6, 2, 3, 5, 4, or whatever. It's just what cards you have together as a group. So for part A, what is the probability of having 5 face cards in your hand? So they're just, these cards are randomly dealt to you out of a 52-card deck. So we're talking about the specific outcomes. We have, there's 3 face cards per suit, so a total of 12 face cards, all right? And so our specific outcome is out of 12, you're getting a group of 5, so 12C5. And then the total possible outcomes is out of 52 cards, you are given a hand of 5, so 52C5. And so if you go ahead and do the factorial stuff and calculate, you're going to end up with this. And we can express the probabilities as a decimal, or as a fraction, or as a percent. So here's decimal and percent. This would be a little more challenging to find the fraction. All right, B, what is the probability of drawing a flush? So a flush is 5 cards of the same suit. That would be cool. So let's see, 5 cards of the same suit. So we know that there's 13 cards per suit. So we have, there are 4 different suits, right? So it's going to be the probability of getting a flush of diamonds, or plus the probability of a flush of spades, plus the probability of flush of clubs, plus the probability of a flush of hearts. So out of 13 cards per suit, we're getting a group of 5. This is our specific outcome. And out of the 52 cards, we're getting a 5-card hand. And we multiply by this 4 here to account for the fact that it's the probability of this plus this plus this plus this. There are 4 different suits. So very unlikely. If it were, what's the probability of drawing a flush of diamonds, then we would cross that out, and it would just be this. And lastly, so if you're playing poker and you get a royal flush, you want to raise the roof and bet everything you own, because this is very unlikely. A royal flush. So a royal flush is ace, king, queen, jack, and 10 of a specific suit. Okay, so either hearts or diamonds or spades or clubs. So there's only 4 of those hands out of all the possible poker hands. And so we would just say 4 over all the possible poker hands, and it turns out to be a very, very small number. Okay, so that's our introduction to probability. We will play some cards, I think, and it's going to be really fun.